My name's Maurice. Don't know if you've heard me speak before. I do quite a bit around JavaScript, Node, trying to teach people that this sort of stuff is coming, whether you like it or not. It has been around for a while. You're going to have to start learning it. And you'll find that when you do start learning, it's actually quite fun, and then you'll move all of your stuff across and you'll never go back to the dark side. So just to reiterate, guys, we're here today because of all these people. We wouldn't be here without them. They give you your snacks, your food, your drinks, free coffee this morning, which I'm taking advantage of. So just make sure if you do see these guys around, give them a big clap. So as I said, guys, JavaScript, yay! This is where the world is going. Everybody's liking JavaScript. Everything's going that way. All the new fancy HTML5 stuff that's coming out, all of the things you can do in the browser these days is pretty amazing. And with Node, we can do a lot of that stuff on the server as well now. So we get a lot of fancy stuff coming around. But you are going to have to learn this stuff at some stage. You do need to become proficient at it. And it's really not that hard. It's just a little bit of a mind shift. So I just wanted to go through what Node.js is. And on the Node.js site, they do have this big block of text that's quite boring and a little bit run down. But to make it a little bit easier, I put it in my own words, or more that I stole something else. So JavaScript is a reindeer. And Node is the robotic Santa that jumps on its back and makes it awesome. Hopefully that gives you a bit of an idea of where we're heading here. So JavaScript's pretty cool on its own. You add Node to it and you can do amazing things. Node.js itself, it's actually made up of a bunch of things. At its core is the Google's V8 engine. So that's the JavaScript engine that they use in Chrome. So you've got everything you can do in Chrome, you can pretty much do in Node as well. There's also a platform abstraction layer. So there is a layer there which is written in JavaScript, and that's which is written in C, which extracts your actual platform, so your OS, whether that be Windows, Mac, Linux, whatever that's running. A Node will run on them all, and there's an extraction layer that then takes the common JavaScript layer, which is their core libraries, and that'll then translate that back down to the OS level. Node itself's on GitHub. You can go and have a look, check it out. Everything's there. If your game, pull requests, there's a few hoops to jump through if you want to try and commit to core, but it's worth it if you can get in there. And the majority of Node is actually written in JavaScript. It surprises a few people that it's not the whole thing written in C. There is a fair bit of C in there, about 17%. And these are just pulled straight from GitHub's percentages. The distribution of that, though, is a bit like this. So it uses the V8 engine underneath. That's what actually runs that JavaScript. So any JavaScript that's handed to it. And then it creates a runtime environment to put that in, and then also exposes that integration level, those bindings, which gives it access to the OS level stuff underneath. And you can see that libuv guy down here. That's the actual event loops and threading system that's involved in Node as well. And I'll go through that in a little bit as well. But in a nutshell, it's just a JavaScript wrapper over your system calls. Just like .NET is just that CLR wrapper over those same system calls on Windows. So guys, how many of us are web developers? Yeah, so we've all got a rough idea what a web server does. Can someone tell me what the main thing a web server does? Yeah? No?
Saves in response to requests.
True. And what would it do if it actually gets that request? Usually it's talking to a database, reading a file off disk, serving static images, that sort of stuff. All of that stuff is I/O. It's always hitting a disk, hitting an external web server, trying to load a file. Does anyone know what's really slow to do on a server? The answer's already up there. Hey. Reading a file from disk is quite slow. Probably one of the slowest things you'll do, unless you've got network response, and that's even slower. And it can be interrupted by disconnects, it can be interrupted by latency, all those sort of things. So anytime you call out to disk or to a network server, someone like that, it's going to take time. And Again, I/O actually blocks threads as well. So if you make a call to go and read a file off disk, you sit there and you wait until that file's been read. If you make a call to a web service, that thread will sit there and wait for that service to come back. And the way to speed that up is to add more threads, right? That's what we would normally do. The more threads you have, the more calls you can make. The more calls you can make, you start talking like Yoda. Threads are dangerous, scary, painful, and they actually chew a lot of memory. They actually can also slow things down if you don't know what you're doing. JavaScript, on the other hand, uses an event loop. So all of the pain that you've had to deal with threads before is gone. You don't even need to know about it. As far as you're concerned, JavaScript is running one thread in the browser, and it's one run thread on the server. Now, to some people that might sound scary, but the way it works is any of these I/O calls, it performs a non-blocking run. So it will take that file read, and it'll hand it off to the event loop, and then continue processing the code that you've written. When that event loop runs the code and comes back, it'll actually hand you back the result, and then your callback will run. Similar to the async and await keywords in .NET, if you've had to play with them yet. I think they're in 4.5, I think. Sounds scary, it's really not, it's quite easy, and I'll show you an example of it in a second. The first part of this is a bit boring. But this is that first example I gave, where in a normal threaded environment, you might read a file, and then you wait for it to be finished. Then you can send a HTTP request, and wait for that to come back, and then we make a query to a database, and then we wait till that comes back. That means at this point in time, we have all the information, and you've only been able to make 3 calls. In an event model system, you can see everything happens pretty quickly up the front. So we'll send a file, we'll send the HTTP request, and then we'll send the SQL query, so we send that off to the database. And we have this available processing time here. We can do something else. Take another request from the web server, run another command or something like that. Then we get the result from our file callback, and then we can process the result. Then we have some free space again. We can do something else. We get the result from our I/O calls, and then we'll get the result from the database as well. So you can sort of see, in an evented model, the threads are still there. There's still a threading system. The event loop handles all that for you. You don't need to worry about that. Even with threads, you're still waiting on process ticks, and it flicks between processes. It handles that all for you, takes it away from you. You don't have to handle any of that pain. And I'll just give you a quick idea of how that works. Hopefully this won't be too scary for any of you. Not that one. So skip this stuff at the top and we'll come back to that. So this is just a basic script to do what we're talking about before. We want to, this is where our code starts. Right? Then we'll start reading a file from disk. And we say, file system, read the file, this particular file. And then we pass it a callback function saying, when that file has been read and you're ready with the data, if you got an error, tell me about it. If not, tell me that you read the file data and log it to the console. Same thing with the HTTP request. Say we're going to call our HTTP request. Let's do a get to google.com and then just log out the status code we got. And then make a database query. Call the database, find me a user whose name is Barry. Come back again. If we got an error, tell me about it. Otherwise, log the data that you got back from the database to the console. And then the end of my code, I've got end demo code. So this code will all run in sequence, one after the other, sequentially as you would expect. But then when that I/O comes back, it'll then process those callbacks. So if we go. So if we have a look at the actual way this has come through, we can see that our start demo code happened. Then we started reading a file, we did the HTTP get, then we called to the database, and then our code finished. All our code ran through without any issues. You can see we got all the way through, down to the bottom, and said end demo code. So all our code has run. And then, after a while, we got the information from the file back. we got the information from the database back, and we got the HTTP call back. You can actually see that the database was the last thing we did, but we got that data back before the response from Google. That's probably because I'm running through my phone and the internet here is not great. And so we don't actually care what order that stuff comes back in, but when we get the data, do something with it. When we reached this point here, we could process more code if we had it, and we could continue to work. So that's not specific to Node or JavaScript. That's the way they do work, but that's just asynchronous programming, the way it goes. It takes a little while to get your head around it, but you'll find that the actual system itself is not difficult. It's just understanding that data flow. So did that make sense to anyone? Did you want me to go through any of this code at all? Yeah. There's a few things in there that I haven't gone through, like how I connected to the database and that sort of stuff, but we can go through that a bit later if you like. Okay. So the other thing that is great about Node is it's solved a lot of problems that we have in other ecosystems. The core thing about Node is the modular system. So in .NET you might have a class or a library that you'd refer to. That would be a certain set of code, you put it in one particular file, or a set of functionality that you've compiled into an assembly. Node has that same idea, and they're called modules. So we might have some code, and Node actually ships with some core modules. That's in that core library, a lot of that JavaScript. And one of those core ones is the HTTP module, which is the one I used to call Google before. We just require that in, and it brings all of that modular code. I hate using the word class in context of JavaScript, but that's what it's done is brought in the HTTP module. It's been able to then use that module to write, and I didn't have to write any of that code myself. Similar to out of the box with .NET, you'll get a whole bunch of system libraries and that sort of stuff come out of the box. It's very easy to use. A lot of you said you had used JavaScript before. Has anyone played with the common JS kind of way of requiring other things in? There's a few other things out there that use this. It's at the core of Node, and that's how it runs a lot of stuff. So to bring in a module, it's very easy. It's just give me a variable that I want to put that code into and require HTTP. Now my HTTP variable has all of the functionality that's in that module and how that's exposed. And that's actually how you can include your own files as well. So I'll go through an example there in a second, but if you have your code all in one big file, we know that's bad. We've been avoiding that for years. The same with this. If you have some code about a particular item, you might want to move that out. You'll refactor that into its own file. You'll expose the methods that you want to be public, and you can hide the things that you want to be private. And when you require that module in, you'll get the public entry points, whether that be functions or properties or anything else that you would normally do. And the big problem that they've solved in Node is package management and dependency hell. .NET's got the NuGet system, where you can bring packages down. I know back when I was doing .NET, I had all sorts of problems where you'd pull down this package, and it required this package version 1, and you'd pull down a different one, and it needed that same package, but it needed 1.1, and they could not possibly talk to each other, and you'd have a whole bunch of problems. You'd have assembly issues all over the place. NPM solved that in the Node space, and part of that is also the way it dynamically loads code, because JavaScript's interpreted rather than compiled. So NPM is very similar to NuGet in the fact that you'll produce a package, now whether that's a 4-line piece of code that you've written, or it might be an entire module. You push that up to NPM, anybody else can pull that down. There are private versions of NPM, same as there is for NuGet. But the beauty of that is you can be from anywhere in your system, you can require those modules in, use them, and away you go. You deploy to a production server, it gets the same version that you asked for and can pull it down. And it also, sorry?
Does that get from GitHub?
It can. So a lot of stuff around Node is very focused on open source, but there's a lot of stuff that is private as well. So for instance, a few of the products that I'm working on at the moment, we use a lot of open source stuff, but there is some stuff that is proprietary to us. We'll have that in a private GitHub repo. And I'll show you the way you can reference NPM modules in a second. And there you can just say get it from NPM. Or if you do have it hidden, you can say get it from this GitHub URL. Or if you have your own private NPM system, you can say go and get it from here instead. And it doesn't matter what OS you're on either. NPM, again, works across everything. Node works across everything. So in our company by itself, we have 2 guys that run Windows, 2 guys that run Mac, and a guy that runs Linux, and we can all write on the same code base. We have no problem switching back and forth. The biggest, hardest, scariest problem we had was line endings on Windows. And that's a setting in GitHub. In Git. It's very easy. So I'll give you a quick demo of how to build a web server. That sounds scary, but again, it's only a few lines of code. And that will also allow us to have a look at this modular system. So that's your basic bare bones web server that will handle probably about 400,000 or 500,000 concurrent connections. Done. Node is very, very fast. It's very, very efficient. And while I said it was single-threaded before, the fact that it hands a lot of that stuff off to the event loop means that it can sit there ready to accept new requests. So you can actually get quite a lot of concurrency out of something like Node. I'll step through this pretty quickly because it is relatively easy. We just require in the core HTTP module. That gives us all that information. So this is the idea of an environment variable. So that's just a setting that might be on the server. If we don't have one, which we don't in development, we'll just choose 8080. We go HTTP, I'm a server, create me a server. And then when we get a request, end the response with hello world and whatever time it is. We just then tell that server to listen on the port that we said. And if there's ever an error, just log it out, an exception. Otherwise, once it's all set up and ready, just tell me that we're listening on this port and we know we're ready to go. Does that make sense? Yep, mostly nods. So this is just setting up an event handler. When that event fires, run this function. Yep. And the same down here. Listen on this port. And this is just a callback to say, when you're finished setting up the listen, then run this code. So what I'll do, I'm just saying node, run that server. And I'm now a web server that can accept all of those connections. So if we now hit localhost 8080, we can see hello world, that's the time. You see that? Right. Refresh that again. You can see the time's actually changing. I'm not cheating. So setting up a web server like that is quite easy. In a production environment, you probably wouldn't expose the node process directly like that. You would probably have a number of servers exposed in this way. You'd have a load balancer in front of that saying, who's the busiest and hand that around. But you can. For small sites, that sort of stuff, there's no reason you can't throw something like that up. Now, that's all of my code in one file there. The only real modular stuff we did was require HTTP. What I've got here is the same code again. But what I've done is I've written this demo module and just put the response.end code in a function. And then this module.exports is exposing the public things you want available in your module. So this thing on itself, when I import this, I'm going to get an object, which is this. It's just going to have a property called respondWithTime, which is this function. Does that make sense? Haven't lost anyone yet? Cool. So now I have the same code we had before, except that I'm just requiring in my demo module. And then instead of putting that function in here, I'm just saying, when you get the request, run the function from my module. Same code, just separated differently. cancel that. We go to server 2. You can see that it still works. It's the same thing. It's just refactored that code out like you would in any other system. Then just to take that one step further, let's say that demo code is really good. I think I've done a good job. I want to make that available to everybody else so they can use it too. I can actually publish that to NPM, and anyone else who wants it can actually pull that down. I've actually done that. There's no reason you can't put one-line stuff up on there. It's probably not very useful to anybody else, but it's there. So let's say I wanted to now use that demo module from NPM. I'll call it by name rather than by referencing the file directly, if we saw before. So this is just a relative where I am demo module. And this is actually calling demo-module, which is the only available non-crappy name I could find in the repository. So what I've done is created demo module. So again, this is the same code we saw before. All I've done is given it a package JSON saying this is its name, this is the version. If you want to run the tests, they'll fail because there aren't any. Where it is on GitHub, who built it, the license, all that sort of stuff. It's just a little package file that tells it everything it needs to know. It will actually generate this for you. You type npm init, and you just answer the questions, and it produces that file. So you don't actually have to type this by hand. We can see if I go to npm.com, go to me, or search if it's going to work. Have demo module. You can see all the information there. It's been downloaded 4 times in the last day. That's probably me. So it's a pretty popular module. Everybody loves it. It's getting a lot of use. We'll actually list out dependencies. So if somebody has used your module in their system and then they've published another module, you'll actually get listed there. Because these things are like Lego bricks. I had the picture up there before. So there's a module out there that does HTTP responses. You might include that in yours because you need to make web service calls, but you're actually calculating the length between 2 cities or something like that. You then publish your thing up, and it'll have a dependency on the other module. Then somebody else might want to actually do a mapping system that works out length between cities and makes HTTP calls. So they can use your module and bring it in. They don't have to write that code. So that modular system brings everything together. So again, we're going to use my code from NPM. We'll just go npm install. Demo module. Goes, hey, where's this thing? What's the latest version? Because I've said get the latest. You can ask for a specific version if you want, and it pulls that down. We will now see in here, if I open the right one, maybe. Always do it live. There we go. We have node modules, which is the folder it puts those things in. And we have demo module. And it pulls that information down. There's a license, all that sort of stuff. You can include tests if you really want to. But now we've done the same thing. We just said use the respond with time function. And again, we'll get exactly the same result. So that's not mind-blowing, but it just shows you the different ways you can move your code around, put them in different modules, that sort of stuff. Okay. So Node has always been known as a web server, good for web development, all that sort of stuff. But it can do other amazing things as well. We actually had an event last weekend called Nodebots, where we were controlling Arduinos and servers and all sorts of stuff, driving little cars around, making beepy jingle bell noises on hardware. There's the Node copter group where you actually fly quadcopters using Node. They've actually done a thing where a group in San Francisco and a group in Brisbane had an event at the same time. The guys in Brisbane drove the copter in San Fran and they drove the Brisbane copter, and in about 2 seconds they both crashed into the wall because they couldn't see where they were going. But there's all this sort of stuff that you can do with JavaScript. My watering system at home that waters our veggie patch, it's all timed and run by JavaScript. Hopefully in 7 to 10 working days, I'll have all my light bulbs will be controlled by JavaScript. And one of the big things that actually got me into Node was, I seemed to do it all the time when I was developing on Windows, is you need to do a thing, you're sick of doing the same thing over and over and over again, so you write a batch script to do it. Batch scripts are hard. That language was written back in the day. That sort of stuff's really hard. I did come across something that allowed you to write .NET code and to then do some magic and compile that down and run that as a script. But JavaScript is a scripting language. That's exactly what I wanted to do. I just wanted to install a module, make it work, make it accessible on the command line. And also, the beauty of this sort of stuff is it will work cross-platform. So if you do write a small module or a utility or something like that, it'll be used on a lot more systems than just a batch script, which you can only do on Windows, and then you have to convert it to Bash to do it on something else. So the beauty of this is that sort of cross-platform, everybody understands it, everybody can use it. You can then also publish that to a global repository like NPM. People can look at the code, they can improve it, you can get pull requests on Git, that sort of stuff as well.
Well, actually, when you download Node, how do you install it? Is it just...
Yep. So on Windows, it's the easiest than any other platform. You click that button.
Okay.
And that's it. That'll download an exe, double click that, it's installed. On Mac, there's a brew system. I think you just go brew, install, however Macs work.
So does that require administrative privileges to do?
Not as of version 9 something, but yeah, not anymore. You can install it. Some of the things you might want to do may require admin privileges. If you're trying to access different areas of the file system, if you're hacking on network sockets or something like that, I think needs admin privileges. But just to get up and running, I don't believe you do. Right, yeah. So I'll just give you a quick idea of a tooling system. So one of the things we were working on a while ago was a system to go to a website, take a screenshot of the homepage, get that, create a bump map out of it, wrap that around a planet, so you can see planet Google with terrain mapped over the pictures of the website. And one of the basic things we needed to do was grayscale an image, which we also needed to run on all the different systems because we were all developing on it, and the server we were going to deploy to was Linux. I ran a Windows machine. I just coded away the way I wanted to create a grayscale image. I pushed it up, everyone used it, and there was no problem with it. I also wanted to make it usable from the command line because it exposes it to a lot more people. So if people want to use it, they can. So I won't necessarily go into that. It's not too difficult. But this is just a function that takes a path to an image, which is a PNG at the moment, takes a path to spit it out, and then fires a callback. That's it. So there's the inputs to the function. It uses another module which somebody else has written called PNG.js, which... Great. Awesome. Let's try turning it off and on again. I'll keep talking so you guys don't get bored watching a projector reboot. So I'll come back and I'll show you that code when it comes back up. But all that does is takes the image, loads a module that somebody else wrote, which was PNG.js, which allows you to work with PNGs in a nice, easy fashion so that I didn't have to do it by hand. So I used their module. I depend on that. I then just use that module to get me each pixel from the PNG. If it was red, green, blue, normalize that down and get me the gray version of that, and then rebuild those pixels up, and then write the file out to PNG. So it's just grayscaling an image, that's all it's doing. But then because I wanted to use that across systems and all that sort of stuff, it's done in Node. I created that in a module and I pushed that up. But I also did a few other things to try and make it available to the command line as well. Right, here we go. If in doubt, turn it off and on again. So that was the pixel stuff I was just saying there. So it just takes the pixels, makes them gray. I won't go into this too much, but I'm creating, at the output path, an image, PNG, plus grayscale.png. I'm piping that information into a write stream, and it's writing out to the disk. Just some of the more fancier things you can do. And when it's finished, call the callback that was passed in. So that's that asynchronous stuff again. So I can say, grayscale this image, and then just keep working. I don't have to wait for it to finish. To make that available on the command line, we do this magic at the top, which probably doesn't mean a lot, but all that does is says to the Node runtime, to the command line, this is where Node is. Go and get it. And that's the same on Mac, Windows, or Linux. That's all over the internet. If you ever need it, copy and paste. You never need it again. I depend on somebody else's library called Commander. That's something else that handles command line arguments, so I didn't have to handle it myself. And I also depend on the async library so that I don't have to create a queue and wait till all of the images are finished by myself. Could do it, but somebody else has already written a library for it. Why bother reinventing the wheel? You can see here all we do is we have a -i, which gives you a list of images, and an output path on the command line, pretty easy. For each of the images, call the grayscaler function. When they're all finished, log done. Pretty straightforward. So now, if I install that, I think it's already installed, but I'll do it again. If you do -g, it will also install globally, which means you don't have to be in the particular folder to call it. So for command line tools, that's quite good. So again, that just goes up, grabs grayscaler and pulls it down, and all the things that it depends on. Now, in my module, I said I want versions between these values or up to this value, or ones that major, minor this, and I'll take any patch after that. Doesn't really matter. You can define that when you set it up. At the moment, this is just set to latest, and it's pulled down Commander 2, Async 2.9, PNG 4.0. I don't really care, because as long as their APIs haven't changed, then my code's still going to work. Now from anywhere, let's go. Say we have the NPM logo there. We just go grayscaler -i, and it was npm.png. Done. Cool. I can run that from a bash script, from a command prompt, from the terminal in Mac. It all still works. And if we actually look here, we should now have a grayscale version of npm. So you can write little command line utilities that anybody can use. You can push them around. It's quite easy. But again, that stuff's all kind of boring when we live in a .NET land. You know, we're enterprise developers. We write big systems, and all those systems are important. You know, we already have a whole bunch of tech that's been written. You know, we're talking to a database. All our business logic is in there. I'm not going to throw that away and start writing everything in JavaScript. The beauty of the modular system is it allows people to write some really cool stuff. So Edge.js is written by Tamaz. He, I think, used to be on the Azure team. I'm not sure if he still is. Works for Microsoft. And he's written a Node module that allows the Node runtime and the .NET CLR to run in the same process and share information. What that means in short is you can call .NET code from Node. which is kind of cool. There is a good presentation from him here where I've stolen a bunch of this stuff from, so feel free to have a look at that as well. Big again. So he says that it connects, that's actually wrong, as of 2 o'clock this morning, they hit 50K 1000 NPM modules. One of those was my demo module. And 17K NuGet packages. So that's all the stuff you have in NuGet, all the stuff that's on NPM, you can now use them together. There's no reason that they have to be a separated ecosystem. It allows your JavaScript code to call C#, F#, Python for some reason, and PowerShell. We have the loose typing system of JavaScript with the strong typing system of the other languages. We've got the IO-bound single-threaded stuff with the CPU-bound multi-threaded stuff. So because you've got the two different systems, you can do some pretty funky stuff. If you do need multi-threading for some reason and you've got the skills to handle that, you can write that stuff in .NET, use your threads as you like, and then from Node, just call out to that module and it'll handle all that. And because it's a .NET conference, cool, with awesome. I think he had them the other way around. So it does that by creating a system between two interfaces. So in the .NET land, I think this is .NET 4.5 only because it requires the task objects. Has anyone had to play with those yet? Ish, yeah. They're kind of new to me because I left .NET at about 4. So, but they're really cool. They're just, again, that same concept I went through before of asynchronous programming in .NET land. So this is your JavaScript call down here. We say, call my .NET function with this information. When it's done, call my callback. In .NET land, it's just a function that takes a task and the information. There is a whole bunch of ways you can use this Edge.js stuff. Some of them are scary crazy. Like you can actually write .NET code that requires in other stuff in a comment in JavaScript and then feed that into it and it will actually compile it on the fly and run it, which is just crazy, but it's there. Don't use it. This is the only way I can actually recommend you use this is if you already have systems, so you are working in the enterprise or something like that, you have all your business logic already in something. You're able to call those assemblies, expose the methods that you want to be able to call, and get that information into a node process. So you needed a very simple API or a web server or something like that across your existing technologies. He's done a whole bunch of performance stats with Edge. In here, smaller is better. So you can see here that this is, you can't actually read that, but that's a node process calling another node module. And that's his baseline, so it's quite small. The one on the right here is a node process and a .NET process talking over HTTP on localhost. So they're just running over a protocol, they're not sharing any information. And the one in the middle is using Edge. So it's, yeah, a little bit slower than calling node to node, but you would expect that crossing that technology boundary. But it's plenty faster than actually putting an interface between the two and talking over HTTP. And that's over localhost as well. There's no network latency, no internet latency or anything across that. And that's only for 22 kilobytes of data. So you get bigger packets and that starts exponentially getting bigger. So I'll give you a quick demo. Hopefully this will be a little more friendly to everybody. Everyone knows what this thing is. This took me a little while to get my head around the brand new stuff. So this is our existing business object that does some really cool stuff, talks to a database, gets secret values from there, does a lot of business logic. But I couldn't get SQL to run. So our secret value is now just a private property. So this might be our existing module. Our class exposed to get the secret value thing, and you need to put in your secret key. If your secret key is this magical number, do this, get my secret value. Otherwise, no secrets for you. Bye-bye. And so this is code that's been running in production, and we want to expose that to command line, to a web server, to whatever we want to do with Node. It's relatively easy to do that. You do need to make some changes because Node can't talk directly to just a normal function like that. You do need to wrap it in the new task library stuff that I was talking about before. .NET, yep. So now we just have, again, a method called getSecretModule has the same signature, takes that secret key, and then we just return the previous function that we've already written, existing module, an existing piece of logic. Now that can do whatever you want to your database, to whatever else you would normally do, and that's fine. You still get that information back to Node. So I'll compile this, because that's what .NET does. And I'll show you the code first. So again, as we saw in the slide before, I just require Edge. That's a module that somebody else has done. npm install that, and away you go. I'm being lazy and just pulling it out of the bin. You probably won't do that, but just the path to your DLL. Saying that's the class that I want to access. It needs to be public, and that's the method that I want to call. And that just needs to have that signature that we saw before. With the task object, async task object. Now you can see I'm getting a warning at the moment here because I've got an async tasks, but I haven't used an await callback or anything like that. It's just warning me that even though you've told it it's async, it's going to run synchronously. And I'll come back to that in a second, but you can see here from code, come back to that too. We just log, we're going to go and get the secret value. Then we call the secret value function, and then we continue processing. When we get that value back, if there's an error, we'll log it. Otherwise, we'll log the result to the screen. Similar to what I did before in that example. So we can see we called the value, and in this instance it waited because that code was synchronous, waited till it got the response, logged that out, and then it continued processing. What we can do is, say you were making an asynchronous call to a database or something like that, and that takes a second. So we're just going to asynchronously wait for a second. You can see that warning went away. So this method is now asynchronous in .NET. It will run and then return, but when it's finished, it'll actually call back with the value. Build. So that same code, I've not changed anything in the JavaScript side of things. If we run that again, we can see that we asked for it, then we continued processing. It waited a second, and then we got our secret information. So you've got that same process that we went through before, but in .NET. One of the other things is really cool is you can still debug this. So if you are doing stuff in Node and you're calling new technology or new methods like this, you want to make sure it works. If something's going wrong, you want to be able to attach a debugger. It's very easy. Normally in another system you'd have a bit more time, but because this is a very simple script, I am going to just put a timeout around that for 5 seconds. So just saying run this code in 5 seconds. Gives me a chance to actually attach the debugger. There's a breakpoint here somewhere. There we go. Remember where that is? Yeah. Alt P, there we go. Cool. So what I'll do is I'll, again, run that. I'll switch back. I'll refresh this, find the node process. And I'll double click. Wasn't fast enough.
Oh man, 10 seconds.
Oops. Doing it live. Cool. So let's try that again. Right there, we flick back here, we refresh this guy. Go to Node, and we double click. So we're now attached to that process. When that timer runs out, you can hear we actually hit the debugger point. We can do crazy stuff like change that secret key to be this number. All right, and then don't press F10 because that'll cancel the recording. How do we even do that? Actually, yeah, F5's all I want, that'll do. All right, then we flick back here. It actually said, no secrets for you. So you've got that same environment that you used to, but you're calling it from a Node process. So guys, that's pretty much all I wanted to show you, and I think we're almost at time. But I'm hoping that that's given you, a very fast, a very quick, very short intro to what Node is, how it works, and hopefully some ways that you can actually start using it today. You don't have to throw out the last 10 years of information. You can actually go ahead and start using that today. Whether it be a little batch script for yourself, whether it be exposing the functionality that you've already written, or even just having a look on GitHub, seeing if there's some stuff that you can help with. So guys, we've got a few minutes if there are any questions. I'm happy to answer them. I'll be around all day if there's anything a bit more complex that you want to talk about. But yeah, thanks guys. Just got one question here, guys.
Yeah, I was just wondering if the file system module, does that work with symlinks?
Yep, it can follow symlinks.
Can you repeat the question?
Sorry. So the question was, does the file system module work with symlinks? So it will follow them. There's a whole bunch of stuff in there about when you get an object back, whether that's a file or a directory and that sort of stuff. You can do a whole bunch of info requests and check if something is a file, is it a directory, is this thing a symlink? So it does handle all that sort of stuff. And that's, again, across all systems. Was there any other questions?
How does it go with email?
Yeah. So the question was, how does it go with emailing? There's plenty of modules out there already that handle that. There's one I'm using, which I can't remember the name of off the top of my head, but that actually works with Amazon Web Service mailing systems. Again, it's a language like any other. You can do anything you want. All the system calls are there. Fortunately, you don't have to do it all by hand. There's a lot of modules out there already. So it's probably a matter of searching the NPM registry to see what's out there and finding one that suits your needs. But yeah, you can definitely do it. I've been doing it myself in a few other projects.
And what about debugging?
Yeah, so it's a good question. It's about debugging. So there is a whole bunch of different ways you can do it. The Node process itself exposes the debugging API. There are visual debuggers, similar to what we just saw in Visual Studio. If Visual Studio is your main editor, you can write Node stuff in Visual Studio and it will debug it for you. They support that. If you're writing it in a notepad or something like that, like I am, and you don't necessarily need a visual debugger. I don't know if everyone's familiar with the debugger keyword in JavaScript, but if you do that in JavaScript, if there's a debugger attached, it will break. That works in browsers now. If you've got a bit of JavaScript running in your browser, put that debugger keyword in and you've got the console open, it'll actually break on that. So we can do the same thing in Node. Again, if I just run that process, but put debug in front of it, we run that, it pauses on the first line, we tell it to continue, it'll hit our debugger breakpoint, we can enter the REPL. Let's say, what's something in there we can actually look at? Probably wasn't a good example. But get secret value from Node is a thing. So we go get secret, got tab completion. If we log that out, it's illegal because it's common. I should have put something in there I can actually access from the debugger. But we can do stuff like, I'll ask for something that's not there, it'll tell you that it's not defined. Let me add something that we can actually get to. Right, so we're now paused on that breakpoint again. Right, we want to see what's in that variable or anything else. We can see that. We can do all sorts of crazy stuff to it. We can also change it, just like you would from any other debugger. Right, so it has that support. I use the command line because I'm used to using with command line tools and that sort of stuff. There is a system out there where you can actually connect Chrome to it and use the Chrome dev tools to debug Node. Like I said, if Visual Studio is already your main editor and you're comfortable using that to write JavaScript, then you can actually debug straight from there as well.
So does Azure now, can you host Node on that?
Yeah, so again, the question was, can you host Node on Azure? You can. You have been able to for a while. Azure actually uses Node for some of their back-end systems as well. Some big places like Walmart, PayPal, those sort of guys, they're all using Node now for a lot of stuff. Doesn't necessarily make them great developers though. There's a thing on Twitter the other day that PayPal have recently switched from Java to Node. When they wanted to change a color across their website, it used to take them a couple of months, I think it was. And with Node, it only takes them a week. So there's savings, but you've still got to do it right. Yeah. So was there any other questions, guys? Yeah, well, one more.
Since this is Pro.js, is there anything that is cumbersome to do in JS that you find is quite elegant or simple in other languages with like Butler or other environments?
Not really. Again, so I'll paraphrase the question if I can. Tell me if I got it wrong. Is there anything in JavaScript that's not as elegant or harder to do? Sorry. Yep. So Node.js is just JavaScript. The only difference from a browser and Node, or at least Chrome and Node, because they're using the same engine, is the window object that you have in a browser doesn't exist. The global object in Node is just global, so you can do a whole bunch of stuff there. So whatever you write in the browser will work on Node unless you're referencing those Windows objects. So from JavaScript to any other language, it's probably more that there are some things that haven't been done, so you may have to do a lot more by hand. There are modules to do quite a lot of stuff now. I'd be very surprised if there's something out there that you have to do by hand nowadays. Not all of them are good, but there's usually something out there. Personally, I write JavaScript all day, every day. That's my main language now. I've never really come across anything that's maybe not as elegant, but definitely the asynchronous way of doing things is a mind shift. And also depends on how you write your JavaScript. So you saw there's a few callbacks that I had in some of that code. It can get a little messy when you're writing stuff quickly like that. And you can get into something called callback hell, where you want to do this thing, then you want to do this thing, then you want to do this thing, and your code starts to, look like this. But if you actually break things out into modules and stuff like that, refactor your methods out like you would in any other language, you don't have that problem because you're just passing references. So again, it comes down to how you write and what you're comfortable with. Personally, I don't, but it does come down to a bit of preference.
One last question. The modules, when it downloads them, does that just download like JavaScript files that you can look into and modify if needs be?
Yeah. So, quick look. So for example, that demo module that I downloaded is there. Yeah, that's the code. The edge stuff is there.
And you can modify that and it will...
If you wanted to. Yep. If you wanted to modify that stuff locally, you could. I wouldn't necessarily recommend it. Because if you wanted to modify it, maybe you should either fork or pull up, but yeah. So guys, I just got the wind up from in the door. There was one more question. If it's super fast, I'll answer that.
It's just like you said you switched from .NET to Node. Is there any things that you would say like, I wish I'd known that from the start? Like,
Yeah. So the question was a switch from .NET to Node. Was there anything that I wish I'd known before? I wish I'd known that I could do this much in JavaScript. I used to think that JavaScript was this, it's a kiddie language. It's never going to get up. You can't do anything in it. It's slow. All of that's completely wrong. It's blindingly fast. You can do anything that you want in it. Especially with Node, you now have access to OS level calls. There's nothing you can't do. And the speed of it is ridiculous. It's as close to assembly as you can pretty much get. It's an interpreted language. There's no compilation. There's no decompilation. But yeah, my advice is just to jump in, have a go. It's really not as scary as it seems. Cool. Thanks, guys. I've got to head off. I'm around all day if you do have any more questions.